Hello and welcome everyone. My name is Jeff Agnoli. I'm with the Ohio Innovation Exchange. It's an initiative of the Ohio Department of Higher Education, and we are hosting today's virtual event. In just a moment, I'm going to introduce our first speaker, but let me just give you a quick overview of our agenda. So I'm going to kick off the program with a very brief introduction, about no more than 5 minutes, about the Innovation Exchange and how we are using this tool to kind of facilitate collaboration across the state of Ohio and beyond. Elena Harkness will be here. She is the PI of the Great Lakes ReNEW Water Innovation Engine and also Executive Director of Current. Brian Stubbs is Executive Director and President at the Cleveland Water Alliance. And John Lenhart is a professor at Ohio State University. He's also going to be speaking on behalf of one of his colleagues from University of Cincinnati. And then Steve Ostanek is president of a company, industry in Northeast Ohio, Nindorfor, and he'll be here in just a moment. Let me just kind of walk you through very briefly what the Innovation Exchange is all about. This is an initiative, as I said, started by the Ohio Department of Higher Education. Really is to drive business and industry connections with the great research and innovations that's coming out of our universities across the state, and also sort of build the economic development engine, which is a great match for the NSF Engines program. I invite you to follow us on LinkedIn so you can stay up to date on all the great events that are going on, and also just the information that we're sharing to the university and research and innovation community. Right now, we're enjoying 10 plus universities across the state. We have several that are in the queue that plan to join the Innovation Exchange. There's no cost to join. The Ohio Department of Higher Education provides this service as a public good, just to make the resources of higher education more transparent and more accessible. There are primarily 3 buckets of data in our search engine. You can search through more than 11,000 faculty experts from all of these different campuses, and filter and screen based on particular research terms or institutions. We also collect and curate research equipment, centers, institutes, laboratories, data sets, and other resources used or available in the research enterprise. And then lastly is we have cataloged more than 30,000 patents or licensing opportunities that are available across all of these institutions, including others that have an affiliation with the state of Ohio. Our primary goals really is to help drive innovation and economic development. And what most companies are interested in is our #1 product, which is our incredible students that graduate with the skills and abilities to kind of quickly work and help a business grow and develop. Another is just sort of connecting with faculty experts and researchers across the state that can help solve problems in businesses or help a business grow and develop beyond its current potential. We also have access to all the equipment, services, as I said earlier, things that can facilitate a company that may or may not have that R&D capacity within their institution or organization. They can readily partner with universities and make that access possible. And then last is sort of all the licensing opportunities or intellectual property that our institutions are generating on a daily basis. Just to give you an idea, a little bit more detail about how that works. These are some of the categories that higher education works to kind of facilitate. So whether we're talking about generic economic development in terms of creating new businesses, retaining companies, meeting the workforce and talent needs that are there. We also have student engagement opportunities that you can talk to us about, whether it's career fairs, internships, capstone seminars, apprenticeships, all those kinds of things. We have chances or opportunities for you to engage with our researchers about projects, short-term or long-term, access to the resources that are available throughout the state through our research institutions. And then lastly, just engaging with centers and institutes that exist in a variety of places. Another way to think about this is this continuum. Many companies, when they get initially involved with academic partnerships, it might start with a simple career fair, just coming here to help recruit students for their company, making people aware of the career opportunities that are available there. It might move next to this next step here where you're engaging with a sponsored research agreement, some kind of short-term or long-term project, ongoing engagement with curriculum and training and education or workshops or in-service, a variety of things that are there. all the way up to sort of a strategic partnership. Now, not all our companies that are engaged with higher education pursue all of these different activities, but the idea is that wherever you get involved in the continuum, we're available to support you and move you along the continuum or support you wherever your needs are. And so that's the primary focus. With that, I'm going to turn it over to a quick demo of our website. So if you'll just give me a second, I'm going to stop sharing my screen and go ahead and open a new window so that you can see what the website is all about. So just one second here. All right. So just a very quick demo of the website. As you can see, we have a slide at the top here that kind of walks you through all the different universities that are engaged. As I said, there's 10 plus institutions that are here. We also have this search engine. You can type in a term, for example, since today's focus is on water, we're going to go ahead and use that keyword search. What comes back is a list of faculty experts where across all the institutions that are profiled, and you can see here, you can filter by a single institution. But what comes back is where the word water shows up on a profile, and the system actually prompts you about where that term is located, whether it be on the faculty member's bio or in their tags or keywords. And as you scroll through, you'll see different information. It could also be a term that shows up on their scholarly works. I'm going to go ahead and choose Professor Tom Dare at Ohio State. He's someone I know and work with and admire. Every profile looks about the same. You can see contact information for them here on the left-hand column. You can also access some of their media like YouTube videos, TED Talks, slide shares. You can also click on their collaboration network and see how they're organized in terms of the researchers that they collaborate with and navigate to any of these other profiles just by clicking View Profile. We can also see just below that is links to department web pages, centers or institutes they belong to, other social media that might be part of their portfolio. A brief bio that describes the kind of work that they're actively engaged with, their title, the availability that they have, and then the keywords associated with their research. All of these data here, the tags or keywords, are auto-generated based on publications that have been submitted. And this is another way to navigate in the system. So when you see sort of a phrase like water resources engineering, you could click on that and then view faculty associated with that keyword. The scholarly work section is how academics basically make their research known to the public. So all of this information is auto-curated again based on things called research IDs. Faculty members simply enter those identifiers and it pulls in their publications as they're being pushed out for public consumption. If it's a public access journal article or publication, you can quickly view it by clicking the View PDF link. If it's not, then you do sometimes have a DOI and you can search for that and see whether or not there's a way to view that publication. It just sort of depends on the publisher. And then the last bit of curated data are grants. Our system surveys over 600 different sponsors, federal, nonprofit, and international. And if a faculty member is listed as the principal investigator or co-investigator or key personnel on the grant, and that information is publicly accessible, that information also flows to their profile. You can always click the Learn More link. That'll take you to the sponsor's website where you can see an abstract of the project, but it gives you a sense of the kind of funding they've received and the projects that they're working on. I'm going to go ahead and click on this logo up here at the top left, take you back to the home page of our Innovation Exchange. And now I'm going to move into sort of the equipment category. And at this time, I didn't type in a word, but I'm going to go ahead and put in the Ohio Water Resources Center, which is a center that you're going to be hearing a little bit about today from Professor John Lenhart at Ohio State. Here you have a brief description of what the center is about, the keywords and so forth that are associated with that center. You click on the title and you get a lot more detail, including a link to their website. So it's a quick way to find that information, and then a brief listing of their research capabilities and contact information, as well as some of the terms that show up in the projects that they work on. This is a fantastic tool because many of our centers also have the ability to list associated faculty. So here's Professor Lenhart's profile, and you click on that to get more information, and his colleague, Professor Linda Weaver's. who's also involved in this effort. And then the last bucket of data, if I go ahead and click back on this logo, I can go to the patent data. And the way this tool works is patents are a little bit harder to index according to faculty members. So again, we're going to just stay with our keyword water since that's our topic. And what I'm getting is a list of licensable technologies that are available across the state of Ohio, regardless of whether the institution is a partner in the Innovation Exchange. We sort of curate, with the help of our vendor, all U.S. Patent and Trademark Office opportunities that are in the system from the last 10 years. So something that's been invented or patented in the last 10 years. You can go through this and look at the information. If you see something that's interest to you, you can click on the title. You'll get a complete record that will probably look very familiar for those of you who look at patents. It's a history of both the inventor, the assignee, the dates and publications and any categories and so on, and any family of patents that are related. We also have the ability to share this. So if you're wanting to share a patent with a colleague or just email it to yourself for record keeping, you can go ahead and click on that share button link and it'll take you back. So in summary, this tool represents one of the most unique and comprehensive coalition-based expertise platforms that are available in the country. When Ohio Department of Higher Ed commissioned this effort back in 2017, there was a lot of work deciding what kind of data industry and colleagues needed across the state. And we've started with these main categories. We're open to your feedback and comments. If you're ever struggling to find a resource, you can come up here to the menu on the homepage under universities, and under the partner universities link, you'll see a listing of all our liaisons from each campus. So if you could scroll through this list and contact that person, these are all professional people who are available to help you answer questions, connect you to the right resources, help you find what you may be seeking. If at any point you can't find or get in touch with someone, by all means, you can click the contact us link here and email us. That will give you direct access to the team that manage this site, and we'll get back in touch with them. Okay, so without further ado, it's my pleasure to welcome to the stage Elena Harkness, who's our first speaker today, and I'm going to invite her to do her own introduction in the interest of time. But thanks again for being here today, and I appreciate your efforts. Take care.
Regional Innovation Engine. And just in brief, so you have a sense of who we are, we're a nonprofit water innovation hub, and we've been around since 2016, and we have a three-part mission. Grow an inclusive blue economy, which for us is all the companies that have high demand for water in our region, as well as the companies that are on the solution side. Help to accelerate innovation. So for all the reasons many of you may know, it's really challenging to get some of these technologies to market, and we try to be a catalyst to do that faster. And finally, we care a lot about solving water challenges. Obviously, in our backyard, there's freshwater issues of all kinds that we are deeply interested in getting involved in and being a part of the solution to, but we're also really driven to be an exporter of technologies that are solving global water challenges. So while we are here in the freshwater region of the world, the vision is really to solve global water challenges. So that's who we are. One of the things Current was set up to do is create cross-sector partnerships. We're really purpose-built for that. We've had research, university, industry, national lab, corporate partners since our inception. And one of the things we have had the ambition to do is bring federal dollars to the Great Lakes region. And so we're here today to talk about our sort of biggest win in that domain, and that's with a partnership called Great Lakes ReNEW. This is one of the inaugural National Science Foundation regional innovation engines. And I won't go into too much background about this program, but just to say I really encourage everybody to look into it. It's very exciting because it's a first-time effort by the National Science Foundation. So not only is Great Lakes ReNEW one of just 10 projects across the country that have been selected, they're the first ever of what is going to become a flagship program of the National Science Foundation, and really their first foray into deeply place-based innovation engines. This is a really exciting opportunity for them to bring in a focus on deeper commercialization, on workforce development, and really thinking about how to marry the people and place assets of our region to drive forward a very grand challenge and vision that I will talk to you about in more detail, but really encourage you to learn more about the program. And also will flag that they've just announced the second wave of funding opportunities under the Regional Innovation Engines program. So there will be more to come. So we were selected because of a big vision around the Great Lakes' role in accelerating resource recovery technologies here in the Great Lakes, but also made for the world, all around the world. And our tagline is turning waste into health and wealth, and especially for the people and places in our region that need it most. And why waste? Well, we are wasting too much of too many different things in our water and wastewater. Today, we lose a lot of energy in the water and wastewater treatment cycle. Huge opportunities to use water and wastewater to generate energy. So really important to meeting our carbon goals, decarbonization goals, and climate future goals that we have here in the region and beyond. We're sending nutrients downstream, very familiar issue in Ohio and Lake Erie, same here where we're headquartered in Illinois, sending nutrients into the Gulf of Mexico. Those problems are often felt, in a mix of our backyard and far away. But the point is, these are valuable nutrients that are in limited supply in the environment that we could be recovering and putting into productive use in other ways. Critical minerals and materials, things like lithium, cobalt, and nickel that we want to use in battery and clean energy production, really critical to our region's ambitions around anchoring the sort of making of technologies that are going to power the clean technology revolution. And finally, all the same technologies that are part of this grand challenge of resource recovery, the things that are used to pull the valuable things out are also very important to keeping the bad things out of our water. And so the PFAS discussion that has really picked up pace in the last couple of weeks with new regulations coming down from EPA, other contaminants as well, heavy metals, things that we don't want in our water, all wrapped up into this big grand challenge around selective separation, better and smarter membranes, and all of the related technologies that will power them. So that's the grand vision that we put to the National Science Foundation, and they backed as one of 10 Grand Challenge regional innovation engines all across the country. And it's a very exciting moment for us here in the Great Lakes. So I want to talk about the region of service for a moment. This is, we looked at the sort of map of the US. This is the map of the potential impact we could have deploying technologies in our watershed. So this is just a look at the Great Lakes watershed and the Mississippi watershed, which is sort of most relevant to the region we're working in. So really a lot of the country could be deeply impacted in a positive way by production and deployment of these technologies here. There's 6 states that we're drawing partners from in ReNEW. And for the first 2 years of this engine, I should say this is a up to 10-year investment of $160 million by the National Science Foundation. But in the first 2 years, we have a focus on just 3, and that's because we want to show really deep impact in 3 places. And those 3 states are Illinois, Ohio, and Wisconsin. And of course, we're here today really to focus on our partnerships in Ohio and the strength of the innovation ecosystem that's already been built around water and the investments that have been built around water innovation in Ohio. So these are a bit outdated statistics. We're working on updating this, but just to give you a sense, only wastewater treatment, that's one part of the total sort of market for resource recovery technologies, which also includes a number of other adjacent industries. But wastewater treatment alone, globally, 38 billion, certainly outdated, growing fast. Here in these states, this is just a rough sketch and probably, again, outdated, and we'll be digging into the details on this. But when we think about what's in the blue economy, we've got a much bigger region when we think about putting these 3 states and their blue economy industries together than we do going it alone. So there was a really strong reason to make this a regional pool. Each of these states, though, already has an emerging market of clusters for water technology in different ways, different strengths that we can build on, but also engaged investors, industries, and utilities. Very importantly, state and local government leadership across these 3 states and a bipartisan commitment to water innovation and what this means for the Great Lakes. Globally significant universities and labs, and talent pools and training infrastructure. And I think one of the great strengths of Ohio has been the vision to invest in the workforce side of this, something that we really hope we can bring lessons and investment opportunities to really bridge the other states in the region that have not been, as leading on those issues. So very exciting. But together, this is where the real potential is I think so exciting for us. Connected testbed capabilities, multi-institution research partners. You're going to hear more from John Leonard about that. Globally significant market driver size, as I said. And again, this idea that this coalition is bipartisan and has a real strong path to regional scale and influence that we want to have at the federal level. So just to give you a snapshot, in Ohio, Ohio State and the University of Cincinnati are two major anchor partners of our research consortium, joined by this wonderful array of others. And we are always open to bringing on new university partners into the mix. We have investors across the table. Again, Cleveland Water Alliance, you'll hear from Brian Stubbs on this, and others across the region that are, located, located across our region. We have utilities and test beds, again, through partners on the ground in all three of these states. And very importantly, we have industry partners who are working in each of these places and have a footprint across the region. And finally, we have workforce development leaders and tables in each of these states that will be knitting together as we work to deliver on ReNEW. So as you can see, it's more than 50 partners already and growing, very large coalition, but we've been building it for, nearly 2 years now. It was May 2022 when this first notice of funding came out from the National Science Foundation. These are organic relationships that have grown over time. We are at the point where we are very close to releasing our first round of subawards that will actually be fueling work that you'll hear more about later today. Two of our leads are on the call, and you'll hear more from them. But I'm just going to give you a real quick highlight into the overall strategy of how ReNEW is going to start to tackle this very ambitious goal. So again, the blueprint already in place and underway in a lot of these states. We have an industry consortium and a research consortium stood up that are actually providing the backbone to start to name and frame the big goals around use-inspired research, around translation, and around workforce development. We have test beds already in place across each of these regions and a vision to create connected test bed capabilities, entrepreneurship accelerator and investment programs, and we'll be creating new ones to fill the gaps, and really essential manufacturing capabilities, including the wonderful opportunity that Ohio has in a Type 1 Regional Innovation Engine Planning Award focused on sustainable manufacturing led by Case Western Reserve University. So a lot of exciting assets to build on there. The engines overall all have a basic three-part structure that I've mentioned: use-inspired research and development, what we call inclusive ecosystem, but is workforce development and inclusive entrepreneurship, and translation, which is really focused on commercialization, getting technologies into the market, testing them out, trialing them, piloting them, and investing in them, and making sure that they're going to scale. Really critical to the whole engine structure is this framework of end users informing the process at every step along the way. So we have an industry consortium, and our research consortium are key to that, as well as utility players and a number of community partners that are helping to drive the research and development priorities across the engine. The goal in commercialization and really bridging from research to translation here is to build technologies from the ideation and like early stage basic bench R&D stage all the way up to full scale demonstration. And so as you can see from the partners we've assembled, all the building blocks and pieces are there. We've been deep into the gap mapping to find out where things are failing to go from one stage to the next and how we can help them succeed and succeed faster. So key activities we'll be focused on in the next 2 years as we build this engine up. We'll be refining the vision and the technical roadmap, launching challenges across material platforms, process technologies, and sensing. That's kind of the core R&D framework, developing and refining our subsystem test beds, and alongside all of that, building out gap-filling programming and translation and workforce development. We have these key 2-year milestones that are about making progress on the grand challenge around selective separation, really driven by this coalition of research universities and industry and utility partners. We'll be working on, this is like the hard work, I think, is knitting together the capabilities of leading water hubs across our region, which we have in Chicago and Milwaukee and Cleveland. Very different capabilities, but again, together, so much more powerful. Launching and investing in water tech companies. So we'll be having our first call for companies to come through multiple tracks of differently focused accelerators later this year. Very exciting, so stay tuned for that. We'll be launching training programs, 500 people for jobs in water, spanning everything from jobs in trades all the way up through higher education. We'll have a fellowship cohort launching that will have fellows across each of our research institutions. So that's very exciting. Working on STEM engagement across the region, technology testbed, and then of course, I think what people don't realize always is that $160 million spread across 10 years across a region this large is a great catalytic start, but not nearly sufficient to accomplish the task in front of us. So we are already hard at work trying to leverage funding, not only from our partners who have a lot invested and have a lot to gain from engagement in ReNEW, but also from the states that are supporting this, state and local support, philanthropic funding, investment capital. So we have our work cut out for us to more than double what NSF has put on the table and to create a framework for real sustainability for this engine going forward. So that's our framework. I hope you're as excited about this mission and vision as I am, and the idea that we can really power something transformational here in the Great Lakes that's going to have the world think differently about how we manage water, to really waste nothing and create a lot of economic opportunity along the way. So I will leave you with a plug that several of the partners here are engaged in some Water Week activities here in Chicago coming up very soon, next week. So definitely scan that QR code. There's going to be a lot of opportunities to learn more and go deeper. And I will turn it over to our next speaker. Thanks so much for the time.
Elena, thank you so much. There was one quick question about how
Sure.
can the industry partners join the coalition?
Yes, we have our first industry consortium meeting next week, which is really very exciting. We are always looking for new industry partners. I will put my email right in the chat. We have a kind of exploratory onboarding process for that, and a very specific framework for expectations of what it means to join the Industry Consortium for Current, which is anchoring this initiative. So Melissa, I see my colleague Melissa Pierce has a hand raised. Oh, I don't know if you can come off mute, Melissa, but
What's her last name?
Pierce, Melissa Pierce. I just saw her hand up, but
yeah, hang on. I can make her talk. Yep, go ahead, Melissa.
Sorry, it was an accident. I was trying to see if my chat was enabled.
all good.
I can't see the chat, so I don't know if people
We'll put Elena's email in the Q&A and you can see that, so no problem. Thanks for clarifying though.
Yep, I'm dropping it in right now.
All right, excellent. I'm going to go ahead and invite to the stage Brian Stubbs with Cleveland Water Alliance. Please give a quick introduction and then you have the stage. Thanks.
Thank you. Yeah, I'm Brian Stubbs, Executive Director and President of the Cleveland Water Alliance. We're really pleased to be part of not only this webinar, but in particular this vision that Elena and others of us have gotten behind, which is, together we can go much further, and that's of much more interest to the Great Lakes and in service of the Great Lakes. So it's great to be here. I just wanted to start with this little quick reminder where Elena kind of finished up, and it's really, talking about what we focus on at the Cleveland Water Alliance, which is more of that TRL from 6 and above, which is where we'll be engaging with this massive kind of Great Lakes watershed. Watershed knows no political boundaries, neither should innovation. But this is really, that TRL from 6 and above that we have a deep focus on, and is one of the pieces that is bringing this to bear. So, look, anybody on this call, I shouldn't have to remind them why I personally think that this vision that Elena had was picked. I mean, it's no brainer where water is going, water scarcity, climate, all that kind of good stuff. And then, of course, our world economy is dependent. Funding for the NSF engines came out of the CHIPS Act, and there's certainly a good portion of this, which is about resecuring a lot of innovation and technology in the United States. And, water, we said, here with us in Cleveland and Chicago, on 20% of the world's fresh surface water. It's a big effing deal, as we like to say. So I wasn't shocked that we landed this as competitive as it was, just because we've got to do better when it comes to water tech. But look, there's a lot of smart people doing smart things, developing tech to secure our water future. But ultimately, we're far behind things like, energy, smart grids, and all of that. So we've got a lot of bright people, a lot of great researchers, but they need our help, and thus they need this collaborative effort. So the Water Alliance, we're an NGO established in 2014, Ohio-based water innovation cluster. We serve all throughout Ohio. We have assets all over the Great Lakes, starting with Lake Erie, but also in the Ohio River Basin. We've got assets even in Canada, across in Ontario, as well as the province of Quebec. Just for knowledge, your 10 full-time staff members, about 6 contracting staff members annually, 2.5 annual budget. And we're operating usually around 2.5, but have raised significantly more money than that in the last 2.5 years or so. So the appetite and eagerness is there, is my point. And so what we do, not dissimilar to Elena and I have had friends for a generation plus in Chicago. So we weren't new to each other and had a lot of respect. And we were just so pleased to be able to bring what we built here in Ohio. So we have over 100 water industry partners that we engage with on a routine, regular basis. I mean, it's much larger than this, but those are the routine, regular players. Over 30 utilities that we play with, and over 23 research, primarily R1 institutions, not only in Ohio, but University of Michigan, Waterloo, University of Buffalo, et cetera. And, on the left, you start to see just a small sample of, some of our partners there from that typical three-legged stool of the cluster concept, along with a lot of great government partners at the local, state, and federal level. And certainly state of Ohio is a big supporter, not only supporting what we do, but financially supporting what we do. And the key programs that we're bringing to bear here for the ReNEW program, starts with the Smart Lake Erie watershed, but it's that second one that's the key point. There's water technology test beds. Elena, mentioned this. There's going to be different levels of them from the bench and the research side, but really, these test beds that can get a product to market is something. When we worked with McKinsey and Company about 5 years ago on asking and answering this question of why don't we see more water tech getting into the market? Well, the answer was actually fairly simple. It was the inability to trial technologies within the environment they were meant to be deployed in, and with customers that ultimately will be that end user, end buyer, and thus getting the voice of customer in there. We also do open innovation challenges, and we have a seed fund, investment fund that we've recently stood up. So look, we're coming in at this from the market. And I can't say that enough. Market focus, what are the areas where there are gaps and where do we see growth? And we pilot that, or we bring that with piloting options and de-risk trials. We make it easy for these market needs and where market growth is to get products piloted, demoed, and de-risk and trialing. We provide them with capital to support that evolution. That's all the way from non-dilutive grant funding all the way up to equity and investments into these companies. And it's this last piece that I love what Elena's built here, because this has always been part of our DNA. It's that anchoring this region to accelerate commercialization and create economic impact. And her vision around that economic impact, which is an inclusive agenda, but it's also saying our area should be known globally as a destination for water tech. And we've started building that here in Cleveland, but we can't do it on our own. So, we're excited by this whole proposition. The open innovation challenges, aligning innovation focus with market need. Good example of this is our lead service line research facility, which was built in partnership with Cincinnati Waterworks, Cleveland, Akron Water, Sandusky. And it's really trialing technologies to detect lead service lines without breaking ground. We built a simulated research facility and pipe system, and there are global innovators flying in. We've got one in this week, another in next week, trialing these technologies, and we've seeded them with non-dilutive grant funding. And then the big ingredient here in supercharging, remember going back to that slide number 2 I showed you of that TRL ready, our test beds. Our test beds are designed around commercialization, getting them into the market. accelerating innovations to market. And look, there's 4 areas that we focus on: our traditional utility test bed, then our open water watershed, digital IoT. Our head of innovation calls it our IoT sandbox, which sounds more sexy, but it's all good stuff. But then our industrial test bed, and then our residential commercial test bed. So here's an example of this. Our water IoT, we know where digital water is going. These compounded annual growth rates are significant, whether it's the sensors, whether it's the IoT devices, double-digit growth through this decade every year. So huge opportunity, and because there's an opportunity, there's a need. So what we did for this test bed is we took the Lake Erie, Ohio part of the Lake Erie Basin, and we first outfitted it with telemetry, the ability for IoT devices to communicate. And then we started playing and landing all sorts of different best-in-class sensors and sensor-based technologies. Through this, over 6,200 square miles of telemetry, 200 IoT devices that serve as benchmarking for testing and trialing the next generation of sensors for just this one particular test bed, the open water watershed. So a good example here is we're trialing near real-time E. coli sensors. We're trying different nitrate sensors this summer. So we're real excited about this, but this also then creates all sorts of cool data-related products, data-related opportunities. So while Lake Erie is now the most digitally connected freshwater body in the world, which we think is kind of cool, you see on the left that all these areas that we're driving innovation technology coming from our, on one hand from our partners such as Case Western, Cleveland State, Kent State, Bowling Green, Wayne State, Buffalo, et cetera. But also we've been bringing in technologies globally that are coming in and plugging and playing into this, and thus creating data as a service models for utilities that have never existed. And we're getting into the wonkiness weeds here, but selling a data product to a utility is a lot easier than selling them equipment to support that data product. So all that will be part of this ReNEW program. We try to make it as easy as possible. And, this is something we'll be scaling up as more innovators come through the ReNEW pipeline, an online version, they can intake what you're working on, what sort of matching from a test bed perspective you need to see. We make it easy. We provide, so we want to grow the test bed asset. We're deploying in the Ohio River this summer. We're deploying later this summer in the Muskegon watershed, but we create that legal infrastructure so we can try things and nobody gets nervous. And one of my favorite parts of this is Lloyd's of London came to my rescue and has provided blanket insurance for all of this, and de-risking, trialing. That makes our utilities comfortable, that makes our cities comfortable, that makes our industrial and manufacturing partners comfortable. And Elena mentioned we also have our Case Western Reserve University Type 1 Sustainable Manufacturing. I'm a co-PI on that one, and we're really anxious to start plugging that work into the ReNEW program as well. It's just so many great potential partnerships. And we also do custom pilots. Right now we're doing a $6 million pilot with Avon Lake Regional Water for on-site generation of high concentrate hypochlorite, disinfecting chlorine requirement by EPA standards for drinking and wastewater. We happen to think it's a good idea to get the stuff off the back of trains, and using an electrical chemical process and salt, we can actually make the process a lot more benign. It's also gone up 3x in price in the last 4 years. So it's been a cost drag for utilities. So again, market. And then as we move forward in partnership with ReNEW and Current, PFAS, we're working on a PFAS demonstration right now as part of the Ohio State Revolving Loan Fund's Emerging Contaminant Superfund access to capital to try different PFAS and PFO technology. Microplastics, we're part of a group that just landed a 7-figure Wayne State program on microplastic sensing technologies. And we did spin out a technology through Case Western that captures microplastics at the washing machine level. So water, energy, nutrients, look, this is going to be broad and big, but again, market. You're going to get tired of me saying that, but I'm going to keep saying that. And really what we're bringing into ReNEW and to you as a researcher is this: evidence-based validation. We're going to de-risk and get you to the market faster, better commercialization. And look, this thing's already popular and we're about to, put it on steroids. Each year we're already looking at 300 innovators comes globally, but we want to see more domestically. Of that, we trial about 30 technologies. So over the last 2.5 years, 70 plus testbed deployments from 13 countries, 12 million raised in support of it, and our seed fund to bring to all the companies within the Great Lakes ReNEW program. So you start to get an idea of what Elaine is building here around, market-based, we don't know R1, we don't know research, but we know when you're ready to have a conversation about what does this look like in the market? Can we pilot it? Can we demo it? We're there. So I'm going to leave you with this. This is where we started, but look at that TRL 6 through 9. Think of us as your best friend. We can bring money in. We can bring partners. We can bring in prototyping, whatever you need. That's part of this ReNEW magic. And of course, open to everybody in ReNEW, incubator and accelerator space. We have hoteling space for businesses, research and industry collaboration. We can hook you up, to that question earlier, to those commercial and industrial partners, market visibility, connection, investment, financing support, prototyping, and manufacturing. So just really thank you. Thanks for having us. And, I'll turn it back over to Jeffrey to introduce our next guest.
Ryan, thanks. Before we do that, there was a question about some of the data that you talked about. Is that available to the public? And how might they engage?
Yeah, reach out to me. I'll put my email in there. We are building those data products now. So yeah, some of them are, and some of them are done in partnership with NOAA to be made available, but we're about to unleash a pretty massive data product. So I'd love to talk to you more about that and then get you to sign up for when we go out of beta with that. But massive data from a research perspective, we can give you special access if you're, i.e. interested in microplastic, microsystem, whatever it may be, let us know. We can get you access to that data.
Excellent job, Brian. Thank you so much. So I am now, my pleasure to welcome to the stage Professor John Lenhart at Ohio State University, and it's your turn to speak. Thanks.
Thanks, Jeff. Can everybody see the screen okay?
Yes, we're
all
on.
right, perfect. I appreciate the opportunity to highlight a little bit of the research that I do and my connection to the Great Lakes Innovation Engine. I'm also going to talk a little bit about my colleague, Dr. Soyoung Che, who's part of this effort as well. He's down at the University of Cincinnati. So again, I'm John Lenhart. I'm a faculty member at Ohio State in the Department of Civil, Environmental, and Geodetic Engineering. I also serve as the associate chair for a department. And then in addition to that, I'm also the co-director for the Ohio Water Resources Center. And I was going to share just a brief one slide about what that activity entails. So in terms of organization, the plan is, so I'm just going to talk briefly about the 3 themes of research that I'm conducting, somewhat related to the activities of the engine as well as some other activities. Talked a bit about the center and then Soyoung. So I kind of organize my research, at least in my mind, in terms of sort of the need or the use for the research or where it's applied. So kind of in this first area, I'm talking about research that's motivated based upon contamination that's in soil and groundwater system, either based upon historical or legacy issues or based upon natural processes. So historically, practices that occurred many years ago under the conventions that were applied at that time have led to inadvertent issues with contamination. So historic mining practices, for example, both in Ohio as well as across the states, led to fairly extensive surface and groundwater contamination. And in many cases, these industries were embedded in the society, and it's not that they intentionally produced this contamination, but it was a byproduct of the work that they were doing. This could include soil and groundwater that is contaminated with different metals or solvents used in mining practices. In the Great Lakes, there's a significant amount of contaminated sediments due to the discharge of industrial contaminants associated with the different industries and manufacturing processes in this country. So that led to contaminated sediments with compounds such as PCBs or polyaromatic hydrocarbons. So we've done research in these areas looking at the processes and mechanisms that are important for understanding where these contaminants are going and how you can develop approaches to clean up these sites. And I'm going to transition to talk a little bit about research with what I call naturally occurring contaminants. So in this case, it's arsenic. And arsenic is a naturally occurring contaminant in groundwater systems, not only in the United States, but worldwide. It's there naturally. It's not necessarily well known, but Ohio has a fair amount of arsenic issues as well. So arsenic in groundwater is fairly widespread throughout the state of Ohio. And this is problematic because about 1.8 million residents of the state of Ohio utilize arsenic as their, or excuse me, don't utilize arsenic. They use groundwater as their primary water supply. And because of that, there's a potential for a significant number of individuals to be exposed to contamination in their groundwater if they're not properly treating it. So one of the things that we're trying to do is better understand in these sorts of rural areas where people are utilizing groundwater as their primary water source, if they're using point of use or household drinking water devices. And if they're not, what are the barriers that are preventing them from doing that? So this is a project that we're looking at currently. And then I'm going to sort of switch gears a little bit and talk about what I call emerging contaminants. So emerging contaminants could be like microplastics that Brian was just talking about, or different algal toxins that he was also mentioning. So we are looking at both of those as well. And certainly the algal toxins are a big issue within Ohio as well, the Great Lakes region. These are produced during seasonal algal blooms. And when these blooms have high concentrations of cyanobacteria or blue-green algae, they can produce these toxins. One of the ones that we've looked at most recently is a toxin called saxitoxin. And this one's interesting because most instances of its production occur in marine systems, and it's very problematic in fisheries where the crustaceans and shellfish as filter feeders can accumulate this, and it is produce what's called paralytic shellfish toxins. So people who eat shellfish that have accumulated these toxins can have very serious consequences. It has started showing up in freshwater systems and in Ohio in particular, and there was a lot of concern trying to understand its presence and how easily it was going to be removed during drinking water treatment. So that was something that we were looking at. We're currently also looking at microplastics. So microplastics, again, as a category of plastics, are those that are 5 millimeters in size or smaller. We're particularly interested in smaller microplastics or the more nanoplastics. And so our work is more specifically looking at the presence of these in drinking water sources and their removal in drinking water treatment. And so I have shown here, just for scale, the different types of microplastics and categories. And so you can see the line for microplastics over here. These are still pretty small, sort of somewhat equivalent to a dust mite. What we're interested in, and this was what makes our work perhaps unique, is smaller plastics, less than 1 micron. So we're talking about plastic particles that are less than the size of the human blood cell. And so we're looking at measuring these both in the intake and in the treated water, and then through the treatment system at our partner utilities. And we have a snapshot of results shown here. And what they do demonstrate is that drinking water treatment is removing the microplastics, which is good. What it is showing as well is that the concentration of particles that are very small, the nanoplastics, are the majority of the plastics that are present in these systems, both in the raw water and in the treated water. And so we're continuing to look at this to identify within specific systems if there are configurations or chemicals that are used in the treatment processes that are enhancing removal or perhaps hindering removal. Then I'm going to switch gears a little bit and talk a bit about final kind of area of research, which is resource recovery. So this is somewhat related to the engine. And our application is looking at mine waters as resources. And so in Ohio, as well as throughout the United States, various mine waters, based upon their interaction with the source material, the ores or mineral bodies that they interact with, can incorporate high concentrations of different elements. For what we're looking at rare earth elements, and coal mine drainage in the greater Appalachian area often has high concentrations of rare earth elements. And we've done some work in Ohio looking at drainages in southeastern Ohio from a number of locations and see high concentration of rare earth elements, and have made some preliminary attempts at developing technologies in order to sort of recover those. We're being somewhat hindered by the high concentration of what are called the fouling metals like iron and aluminum. They're present at high concentrations and sort of hinder the recovery process. But our estimates are such that just in Ohio, that the drainage that is produced could supply up to 2.6 metric tons of critical minerals, which is a significant source of these, and the rare earth elements are important for a variety of purposes. So just in terms of techniques and approaches, so both field work and lab-based work, spectroscopy and microscopy, as needed, we apply advanced statistical analyses as well as numerical analyses in order to determine the outcomes that we're looking at. Just real quick, so as the co-director of the Ohio Water Resources Center, the other co-director is my colleague Linda Weavers. We're one of 54 federally authorized water resources research institutes in the United States. We are the one water resources research institute in Ohio, and our mission is threefold. It's to sponsor research in the water resources area. We also promote education and outreach activities, ideas to try to improve make people more water smart. And so this shows a snapshot of our activities over the past 5 years. And so over the past 5 years, the projects that we've funded through the center have supported research done by almost 90 different investigators. And this is across the state, not just at Ohio State. It's also led to the training of students for professional careers in the workforce. So we are also looking at training the next generation of water professionals. So these 91 PIs are 34 projects at 9 different institutions. We also look for other sources of funding, and based upon the modest amount of funding we get from the Water Resources Research Act, we leverage that by 18 times. And then outcomes from this in terms of an academic sort of viewpoint is in terms of publications. And so our researchers are publishing. And so this provides a transition to talk a bit about my colleague, Soryang Che. So Soryang is one of those investigators who we were supporting early on in his career here. So as the center, one of its missions is to support new investigators in the state, provide them with seed funding to pursue their research. So when Soryang started at Cincinnati about 10 years ago, we were one of the entities that provided him some of his initial seed money to get some of his research projects started. So I'm going to try to switch my slides real quick and pull up a different slide set. So bear with me while I clunk around here. Okay, so are you seeing the right screen on this one, or are you seeing the mixed screen?
Yes, Soryang Che's slides are up. Yep.
Okay, perfect. All right, so Soryang Che, he's down at the University of Cincinnati. He's an associate professor in chemical and environmental engineering down there. And the research that he is conducting is also sort of in 3 different areas. The first is the one that I'm most familiar with, because this is research that he and I have collaborated on for a few years. We both have research interests in removal of cyanotoxins during drinking water treatment. And so in some of his research, he's using activated carbon, which is research that I've collaborated with him on. So we've looked at granular activated carbon and trying to better understand how granular activated carbon can be used for removal of different cyanotoxins, and how the removal differs depending upon whether the carbon is new or whether it's been regenerated. We've recently been awarded continued funding for this sort of research, and in addition to the cyanotoxins, we're going to start looking at PFAS. So coupled removal of both PFAS and cyanotoxins, and maybe even microplastics too. In addition to his activated carbon work, Soryang also looks at reactive adsorptive media. So in this case, he's looking at sort of combined photochemical adsorptive media using a carbon nanotube impregnated with titanium dioxide. So this provides for both removal and destruction. And to some extent, this is consistent with this next area of research that he's pursuing. And this is research that the center had partially funded, at least early on, is in the development of advanced membranes using graphene and graphene oxide. These are novel membrane materials that provide for some beneficial outcomes in terms of both filtration and also in terms of trying to control fouling. Fouling is a pretty significant issue with membrane processes. It's where you get the buildup of the particles or material that you're removing from the water, and it hinders the ability of the membrane to actually treat. So he's looking at trying to develop membranes that have anti-fouling properties. And then in terms of resource recovery, Soryang's looking at nutrient recovery using novel adsorptive media to recover phosphate from wastewater systems. And so with this sort of a system, he's able to develop novel applications for phosphate removal. And snapshot of some of Soryang's funding, and then here's his contact information. And so I think I more or less stayed on schedule.
You did great, John. Thank you. Fantastic. This is an amazing team. First of all, I'm overwhelmed with all the expertise and the talent that we have. So great things are ahead. So keeping with our schedule, we're going to like to invite to the stage now Steve Ostanek from Neuendorfer. And so he's going to provide an industry perspective and also market, right?
Yes, thank you. Let me share my screen. And we'll get going here. All right, so everybody can see my screen?
Yes, we can. Yes, we can.
Okay, great, thank you. So my name is Steve Ostanek. I'm president of Neuendorfer, and I would like to share our insights in how our Environ technology is leveraging the collaborative ecosystem to solve a very big problem for Ohio and also other areas. So first, a little background on Neuendorfer. Neuendorfer is a born and bred Northeast Ohio company that has nearly 5 decades of experience in helping heavy industry improve or enhance their air pollution control equipment. We're a team of 22 people, and our main driver kind of sense of purpose is being part of a proactive way to create a clean and sustainable environment. And I guess my point here is we're not a multi-billion-dollar a year company, but we're trying to solve a very big problem. So it's kind of like David and Goliath, right? So let me introduce you to Goliath. Nutrient pollution is a serious problem in Ohio, especially in the areas in the western basin of Lake Erie. Nutrient runoff on nearly 7 million acres of farmland makes its way into waterways, which then eventually makes its way into Lake Erie and has contributed to those large algal bloom issues that maybe some of us have direct experience with or been impacted by, and most of us have read or seen it on the news. Another part of this story is manure management by the farmers is a very important part of their sustainability. And so you have kind of competing objectives here with environmental stewardness and farm sustainability that you have to try to kind of balance out. And it's been something that we've learned as we've gotten into this thing. So our technology that we're applying here is something called pulsed electric fields. And without boring you to death, it's basically using electrical pulses to rupture organic cells and enhance the biological process that's occurring. Now, the target is our manure lagoons that are on these farms. And back in 2022, H2O Ohio selected our technology as part of a technology assessment program. We were one of 10 technologies selected, for this assessment, and that we were picked out of 40 plus proposals that were submitted. And H2O Ohio is supported by the state of Ohio and has a specific focus on this problem. So we kind of speed up the timeline here, and in 2023, the Ohio EPA who is partners with H2 Ohio, took it upon themselves to apply for a grant from the federal EPA to do a full-scale demonstration of our technology, and they were approved for that grant. So the ecosystem starts getting bigger, and this is where we met with Cleveland Water Alliance, and because we needed a nonprofit partner in this project to make this happen. So together we're collaborating to implement full-scale demonstration on farms of this project. So I'll give you a little overview of what we're going to do. So in the center of the screen is a typical manure lagoon on a farm, and our technology is going to be used to cycle that material, that manure, through our treatment system, and it's kind of going to go in a recycle loop, and then over a period of time we'll stop treating and we'll go into a settlement period, and then the farmer can then apply that liquid on their farms. The important part here is there's two really important nutrients in that lagoon. One is nitrogen and the other is phosphorus. The farmer wants to really apply that nitrogen, and because it's free. That's part of the manure management process is they have access to free fertilizer. The problem is phosphorus comes along for the ride, and the farmer is restricted by how much phosphorus that they can apply to their land. So when they get to that limit, they can't apply anymore, even though they want more nitrogen. So what do they have to do? They have to buy chemical fertilizer. So our process liberates that phosphorus from that organic material and forces it to drop to the bottom of the lagoon. And that creates more opportunity for the farmer to apply the free nitrogen that he has, but also in the future allows the farmer to kind of mine that phosphorus and apply it appropriately at the right times of the season. And I think that's going to become more and more important because the world is running out of phosphorus. So we're either going to have to go to other countries and open up new phosphorus mines, which is problematic, or look at all the phosphorus that we have and just recycle it. So there's a great opportunity here. It's kind of exciting. The impacts are far-reaching. 12 to 15 years ago, this technology was demonstrated in this exact same purpose and had significant impact. 70% or more of the phosphorus was precipitated out of those lagoons. In the case of the geographical region that we're talking about, that would be equivalent to 11,000 tons of phosphorus not making its way into the waterways. Pretty significant. The other thing that was found was, since we liberated the phosphorus from all this other organic material, it was easier for the plants to uptake it. So again, when it's applied, the plants absorb more of it and less of it is washed away if it rains after they applied it and that. So then it made stronger and healthier plants. The reduction in chemical fertilizers is a significant cost impact for the farmers. Just in the case that we're talking about, it's $9 to $10 million annually that would be offset, and that's just going to improve the sustainability of the farmer. They operate on razor-thin margins, and there's a lot of things out of their control. So maybe this is a way that they can get more control. So I mentioned earlier about this collaborative ecosystem, and from our perspective, this is how we see it. So in this case, we're industry. We bring real world market perspectives to the table. We also have ideas that we want to apply. We have resources we can use to do things, to actually get to doing things. Also involved in this are the stakeholders. And in this story, it's the farmers. The farmer brings their real world perspectives to this. They tell us what their constraints are, they tell us what their risks are, and they also may have ideas that we can kind of bake into the solution that we're not seeing. In addition to that, we have the researchers, like folks like Ohio State University. They have ideas, they're working ideas, they're in that TRL 1 through 5. They're looking at how do we scale this thing up to a market condition where we can really test it out. How do we do that? And the other thing that they provide is in this ecosystem, they have technical resources that can validate the results that we're seeing. And we've gone through enough of these things where the kiss of death for a technology is a very poorly planned testing protocol. But to get there, you need a lot of perspectives, because someone might say, well, why didn't you think about this? Well, why didn't you get that data? This is really how it works. And the roadside is littered with great ideas that just couldn't happen. Another entity of this ecosystem is the government. And sometimes we think of government as an impediment, makes things harder. But again, in this particular story, the Ohio EPA has basically created a runway for this technology to take off. And so they're as much a partner in this as anybody else. And last but not least, we have the NGOs. And the NGOs like Cleveland Water Alliance. And I want to take an opportunity here also to give a shout out to Lake Erie Foundation, who's also part of this, and they've been very helpful. The NGOs bring a lot of things to the table. In this case, they have a lot of experience managing these complex grant programs. We don't, but they do, and they can work with that. They also have connections to the stakeholders and the researchers and other resources that could be valuable in trying to commercialize, this technology. That's what we want to see. That's the end game that this ecosystem wants to see. They want to see a solution become viable for the stakeholders and get implemented. And this is kind of how you slay Goliath. So that's my spiel.
Fantastic. Absolutely fantastic. Thank you, Steve. It's absolutely encouraging to hear all the progress that's being made and the technologies and implementation. So we're just at 12:59, which is pretty remarkable. This team, I want to thank all of them for keeping their word and keeping their presentations brief. Just as a follow-up, so everybody knows, our plan is to send out the presentations that were shared today to everyone who is registered, as well as a link to the recording. I'll also download the chat so you can stay in touch with some of the folks that you met here. And maybe I'll send a link specifically to everybody to register. And if they're willing to share their name and contact information, I'll get that out to everybody. But I just want to thank all the presenters. I want to thank the incredible vision of Elena Harkness and the team that put together this proposal. My favorite of all the NSF engines, just so I can say. And maybe NSF will say the same in 2 years, right? My understanding is there's a bit of a competition, right, to get the follow-on funding.
Yeah.
So,
I think
so
that's
not
right.
all of the engine programs will get it. So we want to see this one be successful, and that comes from the great leadership and also incredible partnerships that you've created. So
Appreciate you so much. This is a wonderful, wonderful collaboration that we've built. And yes, there's just so much horizon for us. So
yeah,
thank you, everyone. Look forward to connecting more. Thanks for the platform to share.
Absolutely. So thanks, everyone. We'll stick around if there's any more questions for a little bit, but if you need to drop off, by all means, feel free. I think we had close to 50 show up out of almost 100 that registered, so we're doing great.
Wonderful.
And if
Thanks, everybody.
Yeah, thank you, everybody. If y'all need to be somewhere else, by all means, feel free to jump off.
I do have to hop, but great to see y'all. Thanks
right,
again.
thank
Thank
you.
you, partners.
Thank you.
Thanks, John. Thanks, Brian. Appreciate it. Thanks, Steve. Great to meet you.
Good to meet you.
Bye, everybody.
Bye-bye, Elena. Thank you. All right, looks like we're dropping down to.
Yeah, looks like we're dropping off. Great.
All right, thank you,
Jeff, thanks for the
everybody.
opportunity.
Yeah, oh, you are so welcome. Thank you for sharing everything and good luck with the projects.
Thank you.
Thanks, John
Thank you.
Sure. Thanks, Jeff.
and Brian.
Reach
Pleasure.
Brian, Steve. You guys have a good day.
You too.
Bye.
You
Bye.
too.